I think I let you see last year question. See last year question, see whether I can do it. Last year question is, I wouldn't say it's tough. Last year question, you see, last year I can set can set quite long question, quite tough question, but this year I try not to because it's online lecturing. I don't know how much you pick up, just to be fair. Some lecturer don't care when they say online teaching, just set something not in the notes, something like that, because it's open book, open book. Every lecture is open book. This is a condition. But some lecture think open book very easy, so set question cannot find in the internet and all these things. See whether I can find the question for you. The last year one is I think it's this one. This is the one. This one I went through review already, but I will give it to you. I don't think it's in your notes, but I will get the past year paper solution one towards the end of the semester. I pass it to you. Now, can do this one or not? Compare graphically 3 responses of a second order control system when the input to the system is a unit step function. Graphically 3 responses means the graph is it. That's how I say it come out already. Cannot give it to you again because otherwise they say how come all the time same. I think it's this one. This is the one. The answer this one. 3 graphical responses. You got under damping, over damping, then you got critical damping also. These are the 3 responses. 3 responses. So this is the answer for the first part. But even if this time come out, you also can refer to the notes, open book, isn't it? But if you study in your head, will be very fast. No need to flip the book, then it will take time to do it. Assuming the control system shown in figure Q2A, I think I make it smaller first, because you only see little bit. Make it smaller already, smaller already. So no, it's too small. Some of you make it slightly bigger. 120, slightly bigger will be easier. Right, this system here, part B, assuming the control system shown in figure Q2A has omega n equal 2 radian per second, determine the value of A, the damping ratio, zeta. Now, can do or not this one? Look difficult, isn't it? But actually, it's not. In the lab, I showed you last time can increase this thing, and then you can increase the summing junction to 2 more, isn't it? To 1 more summing junction. So 1 more summing junction. That means you can have something. One of the solutions is to do like that, but you have to calculate the inner closed loop transfer function. I'll show you how to do it. One of the possible solutions is like this. Swing it first. Because in the lab, some of you doing the lab, some of you may not have done the lab yet. This week, Thursday, you're going to do the lab. Now, if you can actually do the thing like that, cut this thing off first. Okay, cut off already. Now I want to draw something. Go back to the pen first. So you want to solve this problem, it's not easy, it's not difficult. Just do like this. This is one way of doing it, but there's an even easier way. But that's it. Because some of you doing lab also do like that. I give you the tip. I uploaded for you already the tip for the first question. 8s 8s squared plus 4a like that, isn't it? Then you got the inner one, you do like this one. Inner one, you do like that. Now this one is too common. You'll be quite common, so you don't be surprised when you see it this year. It's not just do like that. It's not difficult. Just like that. So come to this one, you just go and add in this one. This is 4as. 4 question asks you to find a. I think 90% of students get it. It's not difficult. 4a. Now, so 4a is like that. Now I want to replace the inner one. So I will do like that, isn't it? I will do like this. Hello. Because the inner one is a box already. After I do the inner one. Inner one, everybody should know the answer for this box. This box is CLTF, isn't it? So this is the inner one. Okay. Now I call this one W. This is still 4a. So the characteristic equation, as I said, if you want to find theta or omega n, all these things, you must use a characteristic equation, isn't it? 1 plus GS, HS, and things like that. Now, how can I find W? W is what? W equal to GS, isn't it? GS, I don't write I won't write out the whole thing. This is too, I don't have space. GS is the top, is a box there. So this is 1 plus GS, what is 2a? 2a, just go and put 2a here. 2a is a feedback, isn't it? Feedback path transfer function 2a. So you know W, you know G equal to G actually equal to. That means you got more mathematics to do, like that. You can do one. You can simplify, and then you can find this one. You can find this characteristic equation. Plus 4a. G is like that. So you go and put substitute for G, you calculate. Then you also must do for the closed loop, the characteristic equation here. I think characteristic equation is 1 plus. I'm talking about the final diagram. I wouldn't call it G I call G dash G prime H prime is 4a H prime. So H prime. Now G prime you have to calculate yourself already. You have to put in W first, put in W, put in the G there, then you calculate. H prime equal to 4. This is how you do it. Now don't forget to put equal 0. You don't put equal 0, it won't work. You can't get the answer. Characteristic equation for the lower diagram, for the final diagram, like that. Characteristic equation for the lower diagram is 1 plus G prime H prime, is it? H prime is 4A lah. No, it's 4A. So you go and get the W there. W is actually no. I think I can just put W. You can put 1 plus W 4A, isn't it? Same thing. Or you can say I put it over here. Now for the bottom diagram, 1 plus W 4A. You can start from here. You will get the answer for A equal 0. Now bottom one you do like that. W, you know, isn't it? W is this thing here. W is G over 1 plus G to A. You calculate from here. G is at the top here. You put G here. G 1 over AS squared plus 4A. Put G here. Put G here. Then you can calculate W, isn't it? You know 2A ma. Put 2A there. It will be in terms of A lah. Your answer will be in terms of A, because they all got A there. G got A. Also got 2A there. So W will be in terms of A lah. Then you do like that. You get the characteristic equation 1 plus W 4A equals 0. Also in terms of A. Then you go and use this what? They give some other thing, isn't it? Just how got given other thing. Got given this. I don't know where it is. Not this one. Not this one. Yeah, this is one. Find value of A, damping ratio theta. You are given omega n. You go and make use of omega n. Of course, it's really easy because the equation is like this, isn't it? Just go to this one. So you do like that. The equation is s squared. Now make sure that the s squared has coefficient 1. After you do like this, I go to the top here. S squared equals something, isn't it? S squared equals